Video, I'm going to show you how to do AQA A-Level Maths from June 2018, Paper 2, Question 12. My name is Sunil Tanna. I'm a tutor and author. I'm available for one-to-one tuition both in person and online. I live in Buckinghamshire, England. Question 12. The graph below shows the velocity of an object moving in a straight line over a 20-second journey. Find the maximum magnitude of the acceleration of the object. So if we look at the graph, we can see it shows velocity on the y-axis, time on the horizontal axis, and we can also notice that the velocity has a number of straight line segments. There are no curves, which means within each segment we are able to use the constant acceleration or suvat equations. We also, worth mentioning as well, that the gradient of the graph at any point of a velocity time graph is the acceleration, and the area under the graph corresponds to the displacement, or the area between the graph and the x-axis. Okay, so for part A, find the maximum magnitude of the acceleration of the object. So just by visually inspecting the graph, we can see the steepest part of the gradient, either up or down, is between 12 and 13 seconds. So between 12 and 13 seconds, 12 seconds and 13 seconds, we can use our suvat equation to work out the acceleration. So at 12 seconds, the initial velocity is 12. At 13 seconds, the final velocity, at 12 seconds, the initial velocity is 0. At 13 seconds, the final velocity is -4. The duration here is 1. So we're using A is equal to V minus U over T. We can see that the acceleration at this point is -4 over 1, which is -4. However, we're not quite complete because the question says the maximum magnitude of the acceleration of the object. So what we need to do is just show the magnitude, the size of the number, not the absolute, not the whether it's negative or positive. So the magnitude of the acceleration is 4 meters per second squared. Okay, part B of the question. The object is at its starting position at time 0, t1 seconds and t2 seconds. Find t1 and t2. Okay, so what we can do is look at the area under the graph. So between 0 and 5 seconds, we have a triangle for the area. So 0 to 5 seconds, we can see that the area is 5 across and 2 down. So the area of the graph is 5 times 2 divided by 2, which will give us 5. But of course, it's in the negative direction because it's under the graph. So the area is 5, and the displacement is now -5 meters. Okay, now going forward from 5 to 6 seconds, we have a triangle. So 5 to 6 seconds, we can see that the area for that part is 1 across and 2 up. So 1 times 2 divided by 2, which is 1. So the displacement at this point will be -5 plus 1, which will be 4 meters. And now, so we need another 4 meters. So visually, you can see that each square on the graph is 1 by 1 or 1 meter. So you can see that another 4 squares starting from 6 meters would be to 6 seconds would be to 8 seconds. So from 6 to 8 seconds, the area is 2 times 2, which will be 4, and that will give you a displacement of -4 add 4, which is 0. So we're now at 8 seconds, we're now at our starting position again. So we can say that T1 is 8 seconds. Now we need to keep working forward again because presumably it will, as you can see at 8 seconds, it's still moving forward. So from 8 to 11 seconds, 8 to 11 seconds, it's another rectangle. The area is 2 by 3, which is 6. which can now give a displacement of 0 plus 6, so it will now be at 6 meters. From 11 to 12 we have a triangle. The area is 1 times 2 divided by 2, which would be another 1, again in the positive direction. So the displacement is now 6 plus 1, which is 7 meters. And after 12 seconds it starts going back. So 12 to 13 seconds, the area is 4 down and 1 across. So of course in the negative direction, so 4 times 1 divided by 2 would be 2. So the displacement here will be 7 minus 2, which is 5 meters. Now going from 13, we can see that we'd have another 4 seconds between 13 and 14, and we need another quarter of 4 squares, so 14.25 seconds. So if we go from 13 seconds to 14.25, the area is 1.25 times 4, which is 5. And so the displacement here is, of course, in the negative direction, is 5 minus 5, which is equal to 0 meters. So time 2 is 14.25 seconds. And that completes question 12.